Okay, so in today's lesson, in this video, we're going to start on kinematics. We're going to start on kinematics. So this is the start of motion. So the motion can be in a straight line or in a rectilinear motion in a straight line, non-rectilinear motion in curved path. But I'm only going to focus on motion in a straight line and uniformly accelerated motion. So the motion is uniformly accelerated and it is motion in a straight line. This is what we are going to focus on in our study on kinematics. Right. So, we're going to begin on displacement and distance. Distance and displacement. Distance and displacement. So in kinematics, objects undergo a distance or undergo a displacement. So we'll start with distance. So we're going to start with distance. Distance is defined as the total path length. It is defined as the total path length followed by an object moving from one point to another. That is the distance. Total path length followed by an object moving from one point to another. Displacement. Let's define the term displacement. Now, what do you understand by displacement? This is the distance moved in a specified direction. This is the distance moved in a specified direction. Distance moved in a specified direction. So, further explanation of distance and displacement. I'm going to further explain distance and displacement. Further explanation of distance and displacement. Right. Further explanation of distance and displacement. Suppose an object moves from point A, this is the starting point A, and it follows this curved path length like this, and it goes to point B, right? So this is the curved path length. Can you see? So the total curved path length is the distance traveled. Total curved path length is equal to total distance traveled. Simple. So the total curved path length is total distance traveled. Then displacement. Displacement is directly from there. Displacement is directly from A to B. This is the displacement. So the distance is longer than the displacement. The displacement is short. Can you see it? So I'm moving on to another example another example on distance and displacement. For instance, let's consider the following. Suppose an object is projected from point P horizontal, so it follows this path to point Q on the ground. This is the ground. So the total K of the path length is the distance. Total K of the path length followed by the horizontally projected object is equal to distance. Then displacement is directly from P to Q. So this is displacement. This is displacement. Again, displacement is shorter than the distance. So this total K of the path length is the distance moved. Then directly from P to Q is the displacement. So again, well, therefore, distance is a scalar quantity. Distance does not put into consideration direction. Distance is a scalar or scalar quantity. Displacement is a vector quantity. Displacement is a vector quantity. Now, suppose an object moves from point A there and across total distance of 3 meters, then takes another path of 4 meters to point B. So this is our displacement. Again, the distance is the total path length followed. So distance is equal to 7 meters. Distance is equal to 7 meters. Now displacement is calculated vectorial. So displacement will be A B squared is equal to 3 squared plus 4 squared, which brings us to say AB is equal to 5 meters. So displacement there is 5 meters, total distance is 7 meters. Right? So an object can undergo a total displacement of 0 and undergo. An object can undergo a total displacement of 0, yet undergo travel through a longer distance. Let's consider the following. How is it possible that an object can travel a total displacement of 0 meters here undergo a distance of 50 meters, right? We said distance is the total path length, displacement is the distance moving in a specified direction. This means this object went back to the initial starting point. It means the object traveled such that it returned to the starting point. So if an object returns to the starting point, the displacement is 0. For instance, it can travel like this. So it all depends on the path length followed by the object. It all depends. For instance, the starting point could be A, and then this could have traveled maybe 10 meters, then traveled another 15 meters, going there, then traveled another 10 meters. Okay, so 10, 15, 25, 25, then traveled another 15 meters. So this is the total distance of 50 meters, but the displacement is 0. So it all depends on the path followed by the object. Or an object could have traveled from point A like this, then it goes back, and such that if we measure the total distance, we get 50 meters. But as long as it came back with the initial starting point, it means the displacement is 0. This is basically how distance and displacement are explained in the study of kinematics. So thank you. So in our next video, we are going to look at equations of motion for informal accelerated motion. Thank you.